This brief video will introduce you to the basic concepts of global climate change, and it will serve as a supplement to the text that you're reading. I'll try to point out some different things here and show some pictures that will help you understand the text and will enhance the text. To begin with, it should be clear that climate change is something that's happening now. It's something observable. And one of the ways that we do observe it, particularly along the East Coast, is there is a rise in sea level that we observe. And we're seeing our climate change. And it's hard to know sometimes whether we're seeing a particular climate change phenomenon. But this summer, and some of the extreme weather we've seen in the last decade do fit in with predictions of climate change. One of the clearest indicators of climate change is the rise in global temperature. Basically, global temperature has been tracked very well, particularly since the turn of the 20th century, beginning of the 20th century. And we have seen a rise in global temperature, and this temperature rise has actually been accelerated during the last decade or two. As you know, there are two unit systems for temperature. One is centigrade, the other is Fahrenheit. Since the beginning of the Industrial Revolution, the rise in temperature in degrees centigrade has been about 0.85 degrees centigrade, about 9/10 of a degree, which if you multiply that by 1.8, that's the conversion factor, multiplied by 1.8, you get 1.5 degrees centigrade. So the overall rise in global temperature that we've seen is about 1.5 degrees Fahrenheit. However, since about 1960, where we've seen the biggest rise in global temperature, the rise in temperature has been about 1 degree Fahrenheit. So 1 degree Fahrenheit since 1960, 1.5 degrees Fahrenheit overall. As I alluded to previously, there also has been a rise in sea level. And that rise in sea level has been going on since the beginning of the Industrial Revolution, since the late 1800s. And, this is one of those complicated things. In some places, the sea level appears to have gone up. Other places, it appears to have gone down. But because in some places the land is sinking because of other factors. But overall, on a global basis, we've been seeing a steady rise in sea level on a global basis. And that it used to be the prediction that we would be seeing like 3 feet of sea rise by the end of the century. People are now thinking it's more likely we'll see 6 feet. That's a lot. Another indicator of global climate change is the change in Arctic sea ice. As you can see in these pictures, since 1984, most of Arctic sea ice is disappearing during the summer. And we're looking at some point in the future of Arctic sea ice totally disappearing during the summer. This is a clear indicator. It also will accelerate the rate of climate change because the white sea ice reflects sunlight, whereas the dark ocean will absorb sunlight and cause greater global warming. This will be called a positive feedback. Now, we know that the cause of global climate change is human activities. It's anthropogenic. In other words, generated by us, by human factors. That's the main cause of climate change. There's also some climate change that we've seen since the Earth began, when the climate goes up and down and goes through cycles. But what we've been seeing recently, this rapid change in climate, is an anthropogenic climate change. It's not a natural phenomenon. The basic cause of global climate change is the greenhouse effect. The greenhouse effect is trapping of the infrared component of sunlight in the atmosphere of the Earth. This is a natural effect, but what we're seeing is an increase in this greenhouse effect, an enhanced greenhouse effect that's caused specifically by our emission of greenhouse gases into the atmosphere. So an enhanced greenhouse effect, we understand the science of this very well. There's no doubt that this is happening. Now, the greenhouse gases include methane, nitrous oxide, and several other chemicals that are emitted into the atmosphere. But the most important greenhouse gas by far is carbon dioxide, CO2. And this is emitted by combustion of fossil fuels by humans. And that result of fossil fuel combustion is, the product is carbon dioxide, and that's released into the atmosphere. So that's the main greenhouse gas that we'll be concerned with. So the fossil fuels that we're already familiar with by a previous chapter in the course are basically coal, natural gas, and oil, petroleum, in its various forms. The form we most use it in here in New England is either in gasoline or in heating fuel. So these fossil fuels, they're fossil fuels because they've been left over from an earlier period in Earth's history, are the main, the burning of these are the main causes of global climate change. Now, I'm not sure this means a lot in terms of numbers that kind of resonate in our brains that work well for most of us, but the total amount of carbon dioxide that's emitted into the atmosphere is 31 billion metric tons. A metric ton is 2,200 pounds. So, this is kind of hard to get a grasp on. We think of something being emitted into the atmosphere as a gas, which CO2 is, but now we're thinking of tons of it. So, but this is the number we'll use to try to keep track of it. So 31 billion metric tons. It's a lot. And even though it's still a trace gas in our atmosphere, it has a big impact on climate. Now, the interesting thing is the United States, even though we're not a highly populated country compared to China or India, we got about 4.5% of the world's population, we're emitting, of that 31 billion metric tons, we're emitting something like 5.7 billion metric tons per year. So it's a big chunk of it. And the United States and China together, even though China is much bigger than us, it emits roughly, a little bit more than us, but roughly the same level that we are, even though there's a lot more people. Together, these two countries, the U.S. and China, are emitting about 40% of the CO2 that goes into the atmosphere. So we're important. We make a big impact, particularly the United States, China, India have a big impact. Now, as you'll find out in this course, I like numbers because it gives me better than saying a lot. Or a little. It gives me a kind of a measure of what's going on. And one of the interesting numbers that we will do in this course, and we'll enjoy it, is per capita values. Per capita means per person, per head, per capita. And so if we take the 5.7 billion metric tons of CO2 emitted by the United States per year and divided by the population, which is 320 million people, about 0.32 billion, about a third of a billion people, then we get that in the United States, the average person is responsible for something like 18 metric tons of CO2 per year. So you, through your activities and your purchases, are responsible for about 18 tons or metric tons of CO2 per year. So that's a lot, and it's a lot more per capita than most people in the world. So this is the key thing, and this graph shows the key thing. Because of the industrial activity since the middle of the 19th century, there has been more CO2 emitted into the atmosphere. And because we've cut down so many trees, there is fewer places for that CO2 to be taken up. So that combination of more emission of CO2 and fewer places for that CO2 to be taken up means there has been an increasing concentration of CO2 in the atmosphere. CO2 has been building up. So back in the middle of the 19th century, pre-industrially, the concentration of CO2 in the atmosphere was about 280 parts per million. Now it's about 400 or 404 parts per million. There is every reason to believe this will keep increasing. And there is fear that it could, in fact, double from the pre-industrial level of 280 to twice that, to 560 parts per million. We look at this graph, we see it as a steady rise. There is an up and down motion, and that's because during the winter in the northern hemisphere, there are fewer plants that take up the CO2, and therefore there's more CO2 going into the atmosphere. So this is the most serious problem that we're facing, the most serious cause of global climate change is displayed in this graph. So it's a very important graph. It's important that you understand it and realize what this means. So people are very concerned about the changes in climate. And they're particularly concerned about the level of CO2 because that's such a good indicator of climate change. It's a cause of climate change, but it's also an indicator of climate change. And one of the organizations that tracks this stuff and gives us a report every couple of years is the IPCC, is the Intergovernmental Panel on Climate Change. And so this is a international body that's tracking these changes and letting us know what we could expect in the future. And basically, this is happening and it's going to get worse. And that's what IPCC has been telling us. So most of the impacts of climate change are negative, and will have not only a big impact on many people, their lives, and the economy of the United States and other countries, and an impact on the environment and the other creatures that live in the environment. So we know this is going to happen, and we know that the impacts could be very significant. So, this is a little depressing, no doubt about that. So in this course, we're going to look at not only what is happening and what the cause of it is, but we're going to look at what we can do about it. And there are some things we can do, and we need to start doing them now, and we need to plan to be doing more of those in the future. So this is not a hopeless situation where we just get depressed about it and not do anything. This is a call to action on our part. And we're going to look at the kinds of things that we can do. And a lot of the course is going to deal with these quite positive things about what we can do about changing climate. Now, there are basically two kinds of things that we can do. We can adapt to what's happening, and we're going to have to do that. In fact, we're already in the process of doing that. So we can think, Climate change is going to get worse over your lifetime. So what can we do to make the impacts on our life less? So this of course is based upon accepting that this is happening, that this is a real phenomenon. As you know, there are some people in Congress and elsewhere who haven't accepted the reality of climate change. In order to be able to adapt to it, we have to accept the reality of it, and it's real, it's happening, and we need to begin to adapt. The other kinds of things we can do is to mitigate the problem. Mitigate means reduce it. So do things so climate change won't be as bad. And mitigation means reducing, basically it means in the end, reducing the amount of CO2 that goes into the atmosphere. And so mitigation is something we can do now, we can do more in the future. Once again, we have to accept that this is happening so we can begin the mitigation process. So my point is that there's some positive things we can do. In this course, so we'll look at three things. We'll look at the causes of climate change, why it's happening. We'll look at how we can mitigate it, how we can reduce the amount of climate change. And of course, we'll also look at how we will be forced to adapt to climate change. So this will be an interesting course. It'll be an interesting mixture of things, and most of the things that we will do in the future to adapt and to mitigate are positive things that will make our environment better as we have to deal with this environmental change that is coming at us pretty rapidly.